So we're on lesson 10, or not 10, we're on lesson 3-2, which is estimating our products. So let's dive on in. At the very top, you have another example that you can look at if you need to. So you could pause the video and check it out, but we're going to head straight into our guided practice. So we have Ms. Allen's class sold 700 more items. Estimate to see if her class sold enough items to earn a prize. So this is using our information from our previous page. And if you remember our previous page, they had sold 1,150 items. And so now it's telling us Ms. Allen's class has sold 700 more. So that means we're going to be adding 700. So our key part here is this estimate. So estimate to see if her class sold enough items to earn a prize. So let's check it out. So they have sold how many? 1,850. And if we check, remember we're estimating, so we want to round it. So let's head to our largest place value, the thousands. And remember, we go next door. And what do? If it's 5 or more, we add 1 more. If it's 4 or less, we let it rest. So what is 8? 8 is more than 5. So we're going to add 1 to the place value we underlined. So that means this is about 2,000 items. Now for estimating, we have this little symbol. They're like little squiggly lines for that equal sign. So we're going to now use that number, 2,000 items, and we're going to multiply it by 3 because that's how much each item was. So we have 3 times 2,000, and what does that equal? Well, my basic math fact is 3 times 2, which is 6, and then we add those zeros back on. There's 3 zeros, so we add 3 zeros back on. So what did it equal? It equaled $6,000. And what do we know? Well, we know that they needed to earn 5,000 for a prize. So is 6,000 bigger than 5,000? Yeah, it is. So our final answer after all of our work is yes, enough was sold to earn a prize. And then since it's a complete sentence, make sure we have that period at the end. Heading on to number 2. So our key part here says estimate. So we're not finding the actual answer, we're estimating. So we're seeing what it's close to. So here, 6 times, and let's go to our largest place value and go next door. Remember, I'm going to write my key part up here. If it's 5 or more, we add 1 more. If it's 4 or less, we let it rest. So what is it? Well, it's 2, which is less, so we're going to let that place value rest. Then look to the right, put zeros in sight. So we have 6 times 100, which is 600. Heading to our next one, we have 4 times, and now let's check it out. Head next door, 5 or more, we add 1 more. 6 is more than 5, so we're going to add 1 more. So 2 plus 1 is 3. And then look to the right, put zeros in sight. And what does that equal? 4 times 3 is 12. And there's 3 zeros, so we add 3 zeros on. All right, now to number 4. Go to our largest place value, and let's head next door knocking. And what do we see? We see it's 4 or less. 3 is less than 4, so we're going to let our place value rest. So it's going to stay the same. And then look to the right, put zeros in sight. Our basic math fact is 5 times 3 is 15, and then we add 1, 2 zeros. So 1,500. Now our last one for this group of problems is number 5. So we start at our biggest place value, and we just go next door. Now 1 is less than 4, so remember 4 or less, we let it rest. So our place value is going to rest. It's going to stay the same, doesn't change. Look to the right, put zeros in sight. Then we multiply by 7. Our basic math fact is 7 times 3, which is 21. We have 1, 2 zeros to add. So 2,100. Excellent job, guys. So now we're going to head on down to our next problems. And notice they even broke it down a little bit for us this time. So our first part is we take our biggest number and we're rounding it. So 287 rounds to what? Well, we underline our largest place value, we go next door. And remember, if it's 5 or more, we add one more. If it's 4 or less, we let it rest. So what is 8? 8 is more than 5, so we're going to add 1 to that place value. So 2 plus 1 is 3, and then look to the right, put zeros in sight. And now we're just filling in our next box. So this 287, what does that become? Becomes a 300. So 3 times 3, our basic math fact is 9, and we add 1, 2 zeros, since we have those 2 zeros here. Heading off to number 7. So we're going to look at our biggest place value, and we go next door. It's 4 or less, so we're going to let it rest. So that 1 is going to rest. It doesn't change at all. Then look to the right, put zeros in sight. So we have 6 times 1,000. Our basic math fact is 6 times 1 is 6, and then we add those 1, 2, 3 zeros. All right, our last one for this row, underline our largest place value and go next door. Remember, 62, that's going to be closer to 60 because that 2 is less than 5. So now we have 9 times 60, and I don't know my 9s facts very well, so I'm going to show you a little trick. If you don't know your 9s facts, what you can do is you can make a list of 0, 1, 2, 3, 4, 5, 6, 7, 8. And then what you can do, and then, oh, don't forget your 9. And then what you can do is starting at the bottom where that 9 is, you can do the same thing but backwards. So let's do 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. And so now what's really nice about this is I need to know my math fact of 9 times 6, so I can do 1, 2, 3, 4, 5, 6. And that number right there, the 6th one down, is actually 9 times 6. It's a cool little trick. So I would have 9 times 6 is 54, and I add 1 0 on. Okay, now let's check. For number 9, it's almost the exact same thing. So let's go right here. Round 486 to what? What does that equal? Well, let's check. Go next door. We add 1 more, so that 4 becomes a 5. Look to the right, put zeros in sight. 7 times 5, our basic math fact is 35, and add 1, 2 zeros. And now, is this number close to that number? Yeah, it is, so our answer is reasonable. Heading off to number 10. Round 1,240. Well, let's underline. Look to the right. 4 or more, or 5 or more, we add 1 more. 4 or less, we let it rest. Since it's less, we're going to let it rest. It stays the same. And then we look to the right, put zeros in sight. 1 times 5 is 5 for a basic math fact, and then we add 1, 2, 3 zeros. Is 5,000 close to 9,200? No, it's not. So that means our answer is unreasonable, which means I made a mistake here, so I'd have to go back and check it in real life. Number 11. 9 times 287. So what does this 287 round to? Well, we go next door and we see it's 5 or more. 8's more than 5, so we add 1 more. So that's going to be a 3, and look to the right, put zeros in sight. 9 times 3. Oh, look, we have this little chart that I'm going to use up here. Because I remember I don't know my math facts for 9 very well. So let's do it. We have 1, 2, 3. Ah, so our answer must be 27. And then how many zeros do we add? We add 2. Because there's 1, 2 zeros here. Is 2,700 close to 2,500? Yes, it is. So our answer is reasonable. Let's head on to our now more difficult, but we can still do them, word problems. So our first word problem is, the students voted on a school mascot. Which mascot had as many votes as 4 times the number of votes for unicorns? So there's a lot of information here. So let's do some underlining. We have 4 times, so I'm going to annotate by putting that times above, and we're comparing a mystery mascot, because it's saying which, to the unicorn. So what do I have to do first? I have to look at the unicorn and figure out what is 4 times that. So my unicorn, if I look to the right, I see it's pretty close to 40. So we're going to go with 40 for it. So we have 40, and remember it's 4 times. So now I need to think, what's my basic math fact? Get rid of that 0, and what do we have? We have 4 times 4, which is 16. And then we add 1 0 back on. So let's look. Which one now is close to 160? Well, this one's close to 80. This one, oh, look, it is close to 160. So it must be dragon. So a lot of people wanted a dragon for a mascot. I actually would have wanted the lion, but I didn't get to vote. So number 13, it says, explain how you could estimate the number of students who voted on a school mascot. Then give your estimate. So first we need to explain how many voted, and then we need to give our estimate, say what our answer is. So what can we do? Well, we can round the height of each bar to the nearest tens. And what do we do after we round them? We would add. So, and then add them. So what do we have? Well, this one right here is close to 40. Unicorns is close to 40. Plus the lions, it's not quite at 80, but it's close to it. So we want our estimate. So we would add that. Then our dragons, we already said, was 160. And our owls, it's a little above 20, but we're estimating. So we're going with the one that is closest to. And then our bear, you'll see, it's closest to 40. It's also maybe closer to 50 because look, it's like right in the middle. So I'm not sure what that is. It could be 44, it could be 45. If we said it's 45, notice how that would then round to 50. So let's say it is 45. That means it's going to be 50. So now we would add all these up. And what do we get when we add 40 plus 80 plus 160 plus 20 plus 50? We would get 350 students. So that's how many people were at the school that voted for a mascot. Number 14, Ellie estimates the product of 211 and 6 is 1,800. So we have these two, and she's estimating. Is the estimate reasonable? Explain. Well, let's check it out. 211 should be rounded. Oops, I didn't finish that word. Should be rounded to what? Well, we'll notice that it's going to round down because when I go next door, it's a 1. So it should be rounded to 200. 200 times 6 equals my basic math fact. 6 times 2 is 12. And we add those zeros on. So what is our answer? 1,200 for estimate. Is it close to 1,800? No, it's actually not. And the reason why is even though they both have, let me highlight for you, they both have a 1 in the thousand spot. Notice this 8 and this 2, we're in our hundreds and they're really far apart. They're 600 apart. And we're not in like a super big place value like millions where 600 is not a big deal. We're only in our thousands. So 600 is really far away. In fact, this number that Ellie had, it's 50% bigger than what the estimate is. So that's huge. Number 15. An adult sleeps about 480 minutes per day. I wish I could. I sleep maybe half that. An infant sleeps about 820 minutes per day. Again, I wish my kid would do that, but he sleeps probably 480 minutes. He sleeps like an average adult. About how many more minutes does an infant sleep than an adult? Solve the problem in 2 different ways. So our keyword here is about, so we're probably going to not get the exact answer. So let's check it out. So our first one is 820, that's close to 800. And our second one, 480, well, that's close to 500. But our key problem here is what? We need to find out in 1 week. So this is per day, and we need a week. So how do we get a week? Well, there's 7 days in a week, so we need to multiply by 7. So what do we get with that? Well, let's check. We would get 5,600, and this would be 3,500. And now once we have those, it's saying how many more. So that's a subtraction problem. We're taking the baby minutes, the infant minutes, and taking away the adults. So what would we get when we subtract these? Well, remember, we don't really like it like this, so we need to stack them. And when we subtract, luckily there's no regrouping, so it's super easy. It's 2,100. Now our second problem though is it says solve using two different ways. So what's another way? Well, first I can figure out the difference in 1 day. So 800 minus 500. So in 1 day, our difference is 300 minutes. And then what we can do is we can take that 300 minutes and multiply it by 7, since that's how many days there are in a week, and we would get 2,100. So what's our answer? 2,100 more minutes in a week. Okay, let's head to our last two problems now. You guys are doing great. Beth calculated the cost for tuition. So tuition is what you pay to go to college. College isn't free like school right now in 4th grade. You actually have to pay for it. And for her tuition and books for 4 years, it's $31,800. Which expression shows an estimate to check if Beth's calculation is reasonable? So this word expression, all that is it's like part of an equation, but it's a special part. So an expression is an equation without the answer. So that is the expression. This is an expression. Because notice how we're not solving the expression. So it's saying which expression shows an estimate to check if Beth's calculation is reasonable. So how will we see if her answer is reasonable? We're not solving it, we're checking it. So let's check. We have this number right here, and what it's telling me to do is I think I need to see what that is close to. So what am I going to be looking for? Well, we have this number, 3,180, and we need to break it up into groups of 4. So let's check. 31, what is close to 4 there? Well, if I know my math facts well, I know 31 is close to 32. And so what can we do with that? Well, we can break 32 up into groups of 4. So what is 32 broken up into groups of 4? If I don't know my division, which is okay, I can count by 4s. 4, 8, 12, 16, and keep going. And I will know when I do that, 4 times 8 equals 32. So my answer is 8. So let's see if anywhere in here we can get 8. Now, right here, we have this answer. This is going to be about 80,000. Now we know our answer should be this. So it's not going to be A. And when I look over here, I don't see anything that says 4 times 8. So maybe we have to solve it a different way. Let's look at this chart right here that we ignored the first time. Notice this number right here, when we estimate it, is close to 7,000. And this number right here, this one is close to 1,000 when we estimate. So let's see. We have to pay this 4 times, and we would have to pay this 4 times. Is there something that looks like this in our problem? Yeah, right here and right here. And notice, if I take this 7,000 and add it to this 1,000, I get that 8 that we were looking for up here. So our answer is B. Good job. Number 17 now. Sam and his 2 brothers want to fly to Boston. About how much will Sam and his brothers save buying the less expensive fare? So buying the cheaper one. So it looks like, this is about 300. This is about 400. So it looks like our answer should be 100. So I'd want to mark this. But wait, that was too easy. So let me go back and read it and really check. It says Sam and his 2 brothers. So it's a number 2. So does that mean they bought 2 tickets? They bought 2 tickets, then they would be saving 200. So let's mark that. But wait, there's a problem. What's our problem? It's that Sam probably wants to go with his brothers. So that means we've bought 1 ticket for Sam and then 2 for his brothers. So we've bought 3 total tickets. So if we bought 3 total tickets, that means our answer is C. They will save $300, which is a big chunk of money. Good job, guys. Tomorrow we'll head on to lesson number 3.